So, if I send light like a lantern in a vacuum, zero-gravity space, will I move in the opposite direction of the light? No, light does not have inertia because it has no mass. Therefore, when you send light, such as from a flashlight, lantern, you do not move in the opposite direction. Light exists in the form of electromagnetic waves, composed of oscillations in electric and magnetic fields. Since light has no mass, it does not possess inertia. Inertia is the property of an object to maintain its state of rest or constant velocity when no external forces act on it. So, when you separate an object with mass or expel energy, it experiences a force in the opposite direction. However, light, being massless, does not experience such a force. Therefore, when you emit light from a flashlight, for example, you do not move in the opposite direction. Of course, during the process of emitting light, you can move if you carry the flashlight and move it forward. In this case, both the flashlight and you move forward, but the light continues to travel in the opposite direction. Therefore, in the vacuum of weightless space, when you emit light from a flashlight or similar source, you do not move in the opposite direction of the light. If you send a laser beam that collects light rather than light, will it move? No, laser beams, like other forms of light, do not have mass and therefore do not possess inertia. Sending a laser beam will not cause you to move in the opposite direction. Laser beams are a technology that creates powerful beams by controlling the wave nature of light. Laser beams exhibit all the characteristics of light and do not have mass or inertia. Therefore, when you send a laser beam, you can move during the process. For example, if you hold a laser pointer and move forward while emitting the laser beam, both the laser pointer and you will move forward together. However, your motion is due to the movement of the laser pointer and yourself, not the laser beam. The laser beam continues to travel in the opposite direction. So, in the vacuum of weightless space, sending a laser beam will not cause you to move in the opposite direction of the beam. However, since a laser beam is a concentrated beam of light, it has a higher light density. Therefore, when you receive a laser beam, you may experience a slight force due to the difference in light density. However, this force is very small and not significant enough to cause substantial motion. We are told that light has no rest mass, but only moving mass. Then, we must move according to the law of action and reaction. Isn't this contradictory? The correct answer is that light does not move in the opposite direction due to the law of action and reaction. Light lacks mass and therefore does not possess inertia. Consequently, light does not experience a force in the opposite direction. The law of action and reaction states that when one object exerts a force on another object, the second object exerts an equal and opposite force in return. However, this law applies only to objects with mass. Because light has no mass, it does not conform to the law of action and reaction, and thus, it does not experience a force in the opposite direction. The concept of light having relativistic mass is related to its possession of energy, as explained by Einstein's mass-energy equivalence formula. However, the relativistic mass of light is extremely small, rendering it incapable of experiencing a significant force in the opposite direction. Therefore, it is accurate to say that light lacks rest mass, has relativistic mass when in motion, but does not move in the opposite direction due to the law of action and reaction.